Testing relationships in random samples. Through testing relationships in variables of random samples, researchers have a fundamental concept that allows them to draw meaningful conclusions from data. What is a random sample? A random sample is a subset of individuals chosen from a larger population, where each individual has an equal chance of being selected. This method is crucial in statistical analysis as it helps to mitigate bias and ensures that the results can be generalized to the broader population. Importance of random sampling. Reduces bias. Random sampling minimizes the effects of confounding variables, leading to more reliable results. Generalizability. Findings from a random sample can often be extended to the entire population. Statistical validity. Many statistical tests assume that data is derived from a random sample, making this approach essential for valid conclusions. Testing relationships between variables. Testing relationships between variables involves determining whether a statistical association exists. This is commonly done using correlation and regression analyses. Correlation analysis. Correlation measures the strength and direction of the relationship between two variables. The correlation coefficient, R, ranges from -1 to 1, where 1 indicates a perfect positive correlation. 1 indicates a perfect negative correlation. 0 indicates no correlation. Regression analysis. Regression analysis goes a step further by modeling the relationship between a dependent variable and one or more independent variables. This allows researchers to make predictions based on the data. Level of significance, a key concept. The level of significance is a threshold used in hypothesis testing to determine whether to reject the null hypothesis. Common levels of significance include 0.05, 0.01, and 0.10. Understanding hypothesis testing. Null hypothesis, H0. This is the hypothesis that there is no effect or no difference, and it serves as a starting point for statistical testing. Alternative hypothesis, H1. This is what the researcher aims to prove, suggesting that there is an effect or a difference. Significance levels explained. Alpha equals 0.05. There is a 5% risk of concluding that a difference exists when there is no actual difference. Alpha equals 0.01, a more stringent criterion, indicating a 1% risk. Alpha equals 0.10, a less stringent criterion, allowing for a higher risk of type 1 error. P-values and their relationship to significance levels. The p-value indicates the probability of observing the data, or something more extreme, if the null hypothesis is true. If the p-value is less than or equal to the chosen level of significance alpha, the null hypothesis is rejected. Illustrative example. Let's consider an example to illustrate these concepts. Scenario. Suppose a researcher wants to test if there is a significant relationship between study hours and exam scores among students. Collect data. A random sample of 30 students is selected, and data on study hours and exam scores is collected. Formulate hypotheses. H0. There is no relationship between study hours and exam scores. H1. There is a relationship between study hours and exam scores. Conduct analysis. A correlation analysis yields a p-value of 0.03. Decision. If the level of significance is set at 0.05, the null hypothesis is rejected, indicating a significant relationship. Understanding how to test relationships in variables of random samples is essential for learners in the field of mathematical statistics. The level of significance plays a pivotal role in determining the validity of the results. By mastering these concepts, researchers can effectively analyze data and draw meaningful conclusions. Further reading and scholarly sources. For those interested in deepening their understanding of this topic, consider exploring the following scholarly sources. Statistics for Business and Economics, Anderson, Sweeney, and Williams. Applied Regression Analysis, Draper and Smith. Introduction to the Practice of Statistics, Moore, McCabe, and Craig. By engaging with these resources, learners can enhance their comprehension of testing relationships in variables of random samples and the implications of the level of significance in statistical analysis.